Hello students, this is Miss Dalton, and this video is on solving absolute value inequalities. Recall that when you first looked at the absolute value of x, it is the distance between x and 0. So if the absolute value of x is less than 8, then any number between negative 8 and positive 8 is a solution of the inequality. Because again, remember, the absolute value can be the negative side or the positive side. So you have to look at both sides of that inequality. If you look at a number line that represents this information, you can see that if it's between negative 8 and positive 8, but it's less than that, then we have open circles on each end. So let's look at an example. We're going to solve the absolute value of x minus 4 is less than 3. And so just like in the equations, you will have to isolate the absolute value symbol. Once you get it isolated, you're going to have to set it to the positive value and the negative value. But when we have inequalities, what happens is when you set it to the negative value, you're going to have to reverse the inequality symbol. So let's first look at the positive side. So if x minus 4 is positive, we've already isolated the absolute value symbols, and so then we have x minus 4 is less than positive 3. We add 4 to both sides and we get x is less than 7. Now on the negative side, we've isolated the absolute value bars. We have x minus 4 is less than 3, but when we set it to the negative 3, what we have to do is we have to reverse this inequality symbol right there. And then we add 4 to both sides and we get x is greater than 1. And so now when you write your answer, you want to think, okay, is it possible for a number to be less than 7 but greater than 1? Take 5 for example. 5 is less than 7 and it is greater than 1. So when you write this solution, it is all the real numbers greater than 1 and less than 7. And this can be written as a compound inequality statement where we say that x is between 1 and 7. Now, if we were to graph this on the number line, what I want you to keep in mind is that when you have less than or greater than, you have open circles. If you have less than or equal to or greater than or equal to, you have closed circles. So this will have open circles at 1 and 7, and you will shade everything in between those two numbers. Now, let's look at another example. So now we have the absolute value of 2x plus 1 minus 3 is greater than or equal to 6. And we are going to graph this solution. So our first step is to isolate the absolute value bars. And so when we do that, we're going to add 3 to both sides. So then you will have absolute value of 2x plus 1 is greater than or equal to 9. Now, when we look at the positive side of it, we'll just take that inside the bars, 2x plus 1, and it'll be greater than or equal to positive 9. We subtract 1, 2x is greater than or equal to 8, then we divide by 2, so x is greater than or equal to 4. Now let's look at the negative side. You'll still have to isolate the absolute value bars, so you'll add 3 to both sides, then you'll have 2x, absolute value 2x plus 1 is greater than or equal to 9. At this point, you do want to set it to the negative value, and so you are going to have to reverse the inequality symbol. So you'll have 2x plus 1 is less than or equal to negative 9. Subtract 1, 2x is less than or equal to negative 10. Divide by 2, x is less than or equal to negative 5. So we have x is greater than or equal to 4, x is less than or equal to negative 5. So again, think of a number, and is it possible for it to be greater than or equal to 4, but less than or equal to negative 5? And it is not possible. So we write this as an OR statement. It is the solution of all real numbers that are greater than or equal to 4 or less than or equal to negative 5. This can be written as this inequality, the compound inequality, x is less than or equal to negative 5, or x is greater than or equal to 4. But when we graph this on the number line, at negative 5, we will have a closed circle, and it will be less than, so we will shade to the left. On the x is greater than or equal to 4, we will have a closed circle, and it's greater than that, so it would be shaded to the right. So you can see that on an OR statement, the shadings will go in the opposite directions. So let's look at an application problem on how we can use absolute value inequalities. You work in the quality control department of a manufacturing company. The diameter of a drill bit must be between 62 hundredths and 63 hundredths of an inch. The first thing we're going to do is we're going to write an absolute value inequality to represent this requirement. And then the second part is, does a bit with a diameter of 623 thousandths of an inch meet the requirement? Now, I understand that, you could probably answer part B without doing any math or any algebra. However, we're going to look at this from a coding standpoint. Let's say you are responsible for making a computer program that will determine whether or not a bit meets this requirement by using math. So let's look at our problem-solving strategy. So to answer the first part of this, this question, we're going to write an absolute value inequality to represent this requirement. So we're going to say that D is going to represent the diameter in inches of the drill bit. And we're going to write a compound inequality where D is between 62 hundredths of an inch and 63 hundredths of an inch. Now, we're going to find the halfway point. So this is going to help us as we're writing this code to help determine whether or not a drill bit fits this scenario. We're finding the halfway point because, again, we're going to try and make this into an absolute value inequality, and so halfway determines both sides of the absolute value. So halfway is 625 thousandths of an inch. Now what we're going to do is we're going to subtract that from each part of the compound inequality. So we have 62 hundredths minus 625 thousandths, and then we have, I'm going to let you just read the rest of that. Now once we do that, we can rewrite the absolute value inequality, because what we're going to have here is we're going to get 0.005 on each side of that, and so then we can write that as an absolute value. The absolute value of D minus 625 thousandths is less than or equal to 5 thousandths. And this inequality can be read as the actual diameter must differ from 625 thousandths of an inch by no more than 5 thousandths of an inch. Okay, for the second part, does a bit with a diameter of 623 thousandths meet the requirement? Now, you already know that it does, just as a human, but again, what we're trying to write a code for a program that could just take any drill bit and it could measure the diameter, and then it could tell exactly whether or not it would work. So, of course, the computer program is going to work algebraically. So when we have this, now we're going to plug it into our absolute value inequality, and so the 0.623 is going to go in place of D. We're going to subtract 0.625 from that, and that's going to give us negative 0.002. We're going to take the absolute value of that, and that's going to give us 0.02. 0.002 is less than or equal to 0.005. That is true, so we can see that the bit does meet this requirement. Okay, so hopefully this lesson has been beneficial to you. Answer the questions on the Google form and then come to class ready to work.